Okay, hi, grade nines. So last lesson we talked about translating English phrases into mathematical expressions with our inequalities. So the next step then is to be able to graph them. And to graph them, I'm not talking about like a bar graph or a circle graph. I'm not even talking about the XY coordinate grid. We just need a simple number line. So it's just as easy to just delve right into the first example. So let's do that. Okay, so the first example says more than 370 students went on a field trip. So if you recall, I chose the letter N to represent the number of students that went on this field trip. And you notice just from habit, I was tempted to draw an equal sign there, but it's the equal sign is not appropriate. It says more than 370 students. Okay. So what you need then is pretty much a bare bones blank generic number line. And of course, you're just going to start ticking it off. Do the best you can. Okay. You can also download these and with them sort of done for you, chopped up for you. So whatever number, when you talk about the simple inequalities, the non-complex ones, I would put this number somewhere in the middle. Okay. And it's greater than, so I'm going to actually maybe put it a little bit over to the side here. Okay, so this would be 370. Let's say I'm going up by tens. All right, so this would be 380, 390. This would be, I'm not going to mark them all, but this would be 360 and 350, et cetera, et cetera. So here's what you do. Let's say the way you've translated this English phrase, okay, into something mathematical is to say n is supposed to be greater than 370. So here's how you do it. Okay, and I'm about to talk about an important concept, but just watch the solution first, and then I'll explain why. You're going to draw a circle right at 370. Okay. Now, you're not going to shade that circle in, and I'll get into the reason why. Okay, and then from that point on, you have to kind of use your judgment here. Okay, I'm going to make this a little bit thicker. You're saying, well, look, could there be 300, like, could n equal 380? Yes. Okay. Could there have been 390 students? Could there have been 400 students? Yes. So in other words, all right, everything past this, all right, is good. So this part of the number line does not get a part of this thick red line that I've drawn, okay? That was maybe just a tad too thick, but let's go back to the original circle, okay? Do not shade it in, and then draw yourself a line, because that kind of implies, oh, and by the way, then you have to say n must be a whole number, right? It has to be a whole number. Okay, it can't be a rational number because that would imply 370.5. It would imply 382.3. And you can't have 0.3 of a student. You can't have half a student. You can't have 9/10 of a student. Okay, I'm not going to get too complicated about this specifics. At this point, I'm going to leave that for high school. Okay, just to suffice to say that we're keeping it simple. Draw your circle at 370 and go to the right, because that's where the greater than portion, greater than 370, okay? Greater than 370. We've matched the symbol. The graph matches the symbol. That's when the graph essentially matches the entire expression, okay? So let me pause and talk to you about the types of circles, because you can have what's called these circles are called boundary points, okay? Boundary points. In other words, the circles, okay? The circles. Okay, I'm just going to pause here. So your circles can be shaded or unshaded, and shaded means they're closed, they're open. Okay, and so I'm just going to draw a bunch of, let's just use a neutral color like black, and let's just mark this off. So let's just keep going here. All right. And let's just use a simple number line. So -1, -2, we'll start at 0 in the center. Okay. Now, let's go 1, 2, 3, 4. Okay, let's plot a number of expressions on this number line, okay? And since the number line is black, I'm now going to just switch with various colors. So here's example 1, okay? And I'm just going to use x for all of these. Let's say x is supposed to be greater than 2. Okay, so then what you do is You start with an open circle, okay? And you're just going to draw a red line because to the right because it says x is supposed to be greater than 2. Okay, now watch this. Let's switch colors. Now let's say I'm doing a completely different question and I get a solution of x is supposed to be greater than or equal to, let's go with 1. Now here's what you do. Start with 1, but this time you are going to shade it in because, you might be able to guess, because 1 is a possible solution. It's an allowed solution. It says x is equal to or greater than 1. So because equal to or greater than 1 is an allowed solution, you're going to close the circle. So then you would still draw your arrow to the right because x is supposed to be greater than or equal to 1. Now, in a similar fashion, right, let's just keep switching colors here. So let's say, what if you had x is supposed to be less than -1? Okay, so x is supposed to be less than -1. This number will just give you your starting point. So start with a circle at -1. Then you decide whether you're going to shade it in. We're not going to shade it in because it doesn't include the equal sign, okay, or equal sign. Okay, it's just less than it. So you got to leave it open because -1 is not a possible or allowed solution. And now we're going to go to the left. Okay, we're going to go to the left. Now, let's do one more example. Obviously, you know where I'm going with this. What if it said x is supposed to be less than or equal to, let's use a +2, okay? So now, well, no, I don't want to clutter it up too much. Less than or equal to, let's start with -2, okay. So start with a circle around the -2. I'm making the circles, I'm exaggerating the size of the circles. They don't have to be that big, but I wanted you to be able to see it. Now, obviously, I am shading it in because -2 is an allowed, it's part of the solution. And then I would just draw the arrow going to the left, okay? So whether you shade it in, right? So closed belongs to, actually, let me just color code this a little bit. So with closed circles, let's go with purple. Closed circles, let's just pretend this is a purple dot. Closed belongs to less than or greater than because they have the equals part, okay? Let's use this color, okay? But if you leave it open, right, if you leave the circle unshaded, that is only used for less than or greater than, okay? So let's carry on. You must be 13 years old or older to watch this movie. So the rest of these examples hopefully will be fairly simple. So I'm not going to dwell a lot of time on them. So I think I used the letter A for age. You must be 13 or over. So you can be 13, right? You can equal, your age can equal 13, or you can be older than 13. So let's say 13 is here. We could talk about 12-year-olds, 11-year-olds, 14 years old, and 15 years old. Okay, so this time I'm going to start with a circle here, and I'm going to shade it in because 13-year-olds are allowed to go to the movie, okay? And then you're going to draw an arrow going to the right because all the older kids and adults are allowed to go to this movie, all right? The circle is your boundary point. What it does, okay? And I'll use, I do have a gray here, good. I'll use a thick line. What it does is it establishes this brick wall, okay? It establishes this brick wall. And what we're saying is, whoops, let me just get off the rule here. It's saying none of these kids, the solution doesn't exist over here past this boundary point, okay? You're making a big wall, all right? But for everything past here, the solution does exist, okay? So everything past here, solution exists, all right? I just thought I'd explain that a little bit more because you do this in high school a bit. Okay, children under the age of 5 are free. Okay, let's just tick this off. Okay, let's put 5 over here. 6, 7, 4, 2, 1. Children 5 and, there's your key, and under are free. So if the age is less than or equal to 5, then you're good. So we're going to circle, shade, and draw an arrow. Yeah, that was a bit of a sloppy arrow. Okay. Trying to keep the videos a little bit shorter. You must complete the test in less than 50 minutes. Okay. So again, just mark off, you always start with these blank number lines. Just pick the numbers that would work, that are convenient. So there's 50, 60 minutes, 70 minutes, 80 minutes, 40 minutes. By the way, did you notice I changed this one from the actual, like the last examples? Now I'm forcing you to finish it in less than 50 minutes, not including 50 minutes. So circle, leave it open, okay? I'm gonna make my arrows a little bit thicker, okay? And then you should try and make your arrow straight, but I'm going a little bit quicker now. You can use a maximum of 10 gigs of data per month. Okay, so let's mark off our number line. Okay, so here's 10. Again, just pick somewhere in the middle, right? This is your key word. So data has to be less than or equal to 10, right? Did I actually plot a solution for the last one? So time is supposed to be less than 50 minutes. Sorry, I should have done that. It just occurred to me. So 10, let's go with 11 gigs, 12, 13, 9, 8, 7, 6. Okay, you're allowed a maximum of 10 gigs. So if you nail 10 gigs, you're still okay. So dot, it's a closed boundary point, and it's allowed, you can use 9.9, 9.8, 9, 8, 7, 6. If you use no data, then the phone company is happy because you're paying for nothing. Okay, you must sell at least 35. I think this is the last one. You must sell at least 35 newspapers to qualify for a bonus. Okay, let's see. So sales must be greater than, or you could just get it exactly, just scrape by and get it exactly 35. So mark off parts of your number line here, okay? And say 35, 36, 37. Again, you're going to have to limit your sales. S must be a whole number. You should acknowledge that, okay? Why? Because you're not going to sell 34 and a half, right? So technically, another way of doing this one, when I acknowledge that it must be a whole number, okay, is you could just do a series of dots going this way until you run out of number line room, right? Because what I'm actually showing you, I'm not going to mark you wrong in grade 9 to show the arrow. But technically, the arrow is saying you could sell 34.9 newspapers because it's continuous. It's a continuous, unbroken arrow, whereas really you should use dots. But the point is, if you look at this, right, let's just use this. Okay, your boundary point establishes a boundary, right? And we're saying no bonus for you. Let me go off the straight line here. No bonus for you if you sell less than 34 newspapers. Oh, shoot. You must sell at least 35. Guys, guess what? The boundary should have been here, right? My bad. Yikes. Okay, hang on a sec. All right, let's, okay, hang on. I do want to fix this, sorry. You guys get the idea. But nevertheless, I'm trying to be picky about this. Okay, here's your boundary point. Sorry about that, guys. Okay, there's your boundary point. Okay, much better. So if you sell 34 newspapers or less than 35, you're no good. Okay? All right, here the solution exists, right? We'll put green for money. All right, so you get money, you get your bonus for selling over here, okay? Again, technically it's dots, whatever. You can use an arrow. Okay, that's it. That was simple inequalities. Next we'll do complex. Okay, take care, grade 9s.